Let us discuss carbonyl compounds. In the carbonyl compounds, we'll see Cannizzaro reaction. In the Cannizzaro reaction, we have discussed intramolecular Cannizzaro reaction. In that, one more equation we'll take. So, in that reactant is benzene, we have taken here CHO, here CHO, dialdehyde it is. Next, it is connected to another benzene, that means biphenyl. Here one aldehyde group, here one aldehyde group. Okay, like this we have taken. In the presence of a concentrated alkali, in the presence of concentrated alkali, what we will get, we will see. Now, if OH minus is attacking this aldehyde group, if OH minus is attacking this aldehyde group, what will happen? We'll see. OH minus is attacking aldehyde group, isn't it? Aldehyde carbon. So, OH minus is attacking this aldehyde carbon. Therefore, this CH, that O becomes O minus and OH. We have written. Then another aldehyde group here. Next, when one OH group is attacking one aldehyde group, another OH group will attack another aldehyde group from this phenyl ring, not in this phenyl. Okay. From this phenyl ring, one aldehyde group will be attacked by OH minus. Which one in the sense? This aldehyde carbon, not up, down aldehyde carbon. Okay. So down aldehyde carbon will be attacked by OH group. Okay. Here aldehyde group is there. What is the next step? Migration of H minus. Correct? Migration of H minus. So this bond is shifting. Here lone pair is shifting like this. This H minus attacking here. Similarly, here what happens means this bond is shifting here towards H. Towards H. So lone pair is shifting here. Pi bond is shifting here. It is attacking the carbonyl carbon. Okay. So what we will get, we will see. Here phenyl ring. Here another phenyl ring. This part becomes carboxylic acid. Carboxylic acid. This part becomes alkoxide. That means CH2O minus. Then here this part becomes carboxylic acid. Carboxylic acid. This part becomes alkoxide. CH2O minus. Correct? Now H plus transfer. From here to here H plus transfer. Now we will say H plus transfer, we will say H plus is transferring. So we can say here C double bond O minus, here CH2 OH we can say, here COO minus, here CH2 OH we can say. Okay. Next, what we can say in the sense, if we give acidic medium, this will become OH, this also become OH. Then between them, between this OH and this, hydrogen bonding is possible. Here also between them, here hydrogen bonding is possible. Due to hydrogen bonding only, here we have taken opposite. When OH minus is attacking this carbonyl group, another OH minus attacking this down carbonyl carbon, not up. Okay. So one OH minus attacking up aldehyde carbon, another OH minus is attacking down aldehyde carbon. Okay. Sir, this is called intramolecular Cannizzaro reaction, we can say. Next, we will go for Perkin reaction. Next, we are going for Perkin reaction. Here, in this Perkin reaction, we have to take aromatic aldehyde. We are taking aromatic aldehyde. Okay, we are taking aromatic aldehyde. Then, anhydride of aliphatic acid containing 2 alpha hydrogens. Anhydride of aliphatic acid containing 2 alpha hydrogens. So, now here for this aliphatic acid, corresponding aliphatic acid in the sense acetic acid, it's anhydride, acetic anhydride. this this should have at least two alpha hydrogens, at least two alpha hydrogens. Okay, now this is a functional group carbon. This carbon is directly attached to functional group carbon, therefore it is alpha carbon. These hydrogens are alpha hydrogens. Here how many alpha hydrogens means here 3 is there, here 3 is there, but we want how many? At least 2 here, at least 2 here, but 3 here. Okay, at least 2 alpha hydrogens should be there, but 3 alpha hydrogens are there. Okay, more than required only is present. Okay, next we have to treat this with sodium salt or potassium salt of same this aliphatic acid. Aliphatic acid is what? Acetic acid. Here aliphatic acid is acetic acid. That aliphatic acid in the form of sodium salt or potassium salt we have to take. Then what we will get, the obtained compound is taken for hydrolysis. We are getting the compound called alpha beta unsaturated acid. Alpha beta unsaturated acid we are getting. Alpha beta unsaturated acid we are getting. So what is the mechanism involved here? That we'll see. We'll see the mechanism involved in this one. Okay, now this acetate ion we will take. In this one acetate ion we are taking, that is CH3 C double bond O, O minus. Okay, this acetic anhydride will take, acetic anhydride. Acetic anhydride, what happens means removal of water. That means instead of removal of water we can say this base is abstracting this proton. This bond is shifting to carbon and becomes carbanion. This is leaving as acetic acid. This acetate ion is leaving as acetic acid. This is carbanion we can say. So we got a carbanion, we got carbanion. This carbanion is attacking benzaldehydic carbon. This carbanion is attacking aldehydic carbon, it is attacking. So we'll take benzaldehyde. We'll take benzaldehyde. Here aldehyde group we will take. Okay. Now attack will be there. How the attack is there, we'll see. This lone pair is attacking this carbon. Therefore, this pi bond is shifting to this oxygen. Okay. So like this attack will be there. Now phenyl ring will take. Phenyl ring, this becomes O minus. The CH, this becomes O minus. This O is having 3 lone pairs. Then this carbon is making bond with this carbon. So CH2, this COO, COCH3 will write. COO, COCH3 we have written. Okay. Sir, next step we will see. This O minus takes H plus. This O minus takes H plus from acetic acid. Therefore, it becomes OH. This phenyl ring. Here we can write this phenyl ring will write that O minus becomes OH. It is taking H plus from acetic acid. Here CH, this O minus become OH. Here CH2. Here CO, O, CO, CH3. Okay. Then we'll take this for here. From here, what happens means dehydration is possible. Dehydration means removal of water. How that water is removed, we'll see. This bond is shifting here, this bond is shifting here. So water is leaving. Water is leaving. So what we will get? That we'll see. This phenyl ring, CH double bond CH, CO, O, CO, CH3. It is taken for hydrolysis. It is taken for hydrolysis. Here this bond is breaking. This side H plus, this side OH minus. It is leaving as acetic acid. it is leaving as acetic acid. Actually, it is leaving as acetic acid. So this we are getting as a pH CH double bond CH single bond COH. So we are getting carboxylic acid. This carbon is directly attached to functional group carbon. So it is alpha, it is beta. So alpha, beta unsaturated. That means between alpha carbon and beta carbon, pi bond is there. Alpha, beta unsaturated acid we are getting. Alpha, beta unsaturated acid we are getting here. Okay. So in this Perkin reaction, what is the product in the sense alpha, beta unsaturated acid? This acid name is called cinnamic acid. This acid name is called what in the sense cinnamic acid we can say. This acid name is called cinnamic acid. Okay. Now next reaction we'll see in the Perkin reaction continuation we'll see. Now we'll take a benzaldehyde. We are taking benzaldehyde. Then we'll take anhydride of aliphatic acid containing 2 alpha hydrogens. Anhydride of aliphatic acids containing 2 alpha hydrogens. This anhydride will take anhydride. This we have to treat with which one in the sense its corresponding acid sodium salt. Its corresponding acid sodium salt is this one. Okay, its corresponding acid sodium salt is this one. Okay, sir. Then the resultant we have take for hydrolysis. Then we will get alpha beta unsaturated acid. Okay, so first step we will see this base is converting this into carbanion. Okay, so now first step we will see this base will take this CH3 CH2 COO minus. It is this O minus is abstracting alpha hydrogen from here. So we will take this is CH2 CH3 COO CO CH2 CH3 we have taken. So abstracting proton. Okay, this O minus is abstracting proton. This O minus is abstracting proton. Therefore, this is leaving as carboxylic acid. So this becomes carbanion. That becomes carbanion we can say. So here CH3 COO COET. Okay, like this we got. This carbanion is attacking this benzaldehyde. That carbanion is attacking this benzaldehyde. So this C minus is attacking this carbon. This pi bond is shifting here. So we can get this pH CO minus here H. Here we can write CH3. Then the COO COET. Next, this O minus becomes OH by taking H plus from this carboxylic acid. From the left carboxylic acid, it takes H plus. Therefore, it is becoming pH CHOH. There is CH3. Then COO COET. Okay. Then next step, removal of water. Removal of water. This bond is shifting like this. This bond is shifting like this. So water is leaving. So leaving of water, we will get what in the sense pH CH double bond CH C double bond O C double bond O ET. Okay. Next, it is taken for hydrolysis. It is taken for hydrolysis. So what happens means here H plus, here OH minus. It is leaving as carboxylic acid. It is this we are getting a pH CH double bond CH COH. That means alpha carbon, beta carbon. Alpha beta unsaturated carboxylic acid we are getting. This is called what in the sense here methyl group will be there. This is not H, it is methyl group. Okay. So here we have to give one methyl group we have to give. Instead of this hydrogen, we have to give methyl group. So here we are giving methyl group. So at alpha position, methyl group is there. Therefore, alpha methyl. Then remaining thing is called what in the sense cinnamic acid. Remaining thing is called cinnamic acid. Therefore, we can say it is alpha methyl cinnamic acid. We can say. Sir, this is about Perkin reaction. In the Perkin reaction, what we have to take in the sense, one is aromatic aldehyde we have to take, another one is anhydride of aliphatic acid containing at least 2 alpha hydrogens. Then here sodium or potassium salt of this corresponding carboxylic acid. Then the resultant should be taken for hydrolysis. Then we are getting alpha beta unsaturated carboxylic acid we are getting. Okay, it is called a Perkin reaction. Now we will take a aromatic aldehyde Perkin reaction continuation. Aromatic aldehyde will take aromatic aldehyde containing anhydride group, aromatic aldehyde containing anhydride group we are taking. So aromatic aldehyde containing anhydride group we have taken. Okay, now what is taken in the sense, sodium salt of aliphatic acid we are taking, and warming the contents. So what will happen, that we'll see. So this base is abstracting proton. Which proton it will abstract? This base is abstracting proton. Which proton in the sense, this proton. So now we will take this phenyl ring, this CHO will write, this is CH2, this is CH2. Here what means? CO, O, CO, CH2, pH, like this is that. Now acetate will take, now this O minus is subtracting proton, this bond is shifting to this carbon, this sigma bond is shifting to this carbon, we can say. So now we can say this phenyl ring, we can say this aldehyde group we will write, here we will write CH2, here we will write CH, lone pair, negative charge. Then here we will write CO, O, CO, CH2, pH. Then this lone pair attacking this carbon, this pi bond is shifting to this oxygen. Okay, so what membered ring we will get? We will see this carbon and this carbon making bond. It is what membered ring? 1, 2, 3, 4, 5 membered ring we are getting. Okay, so we are getting 5 membered ring. So here phenyl ring we will write, here we will write 5 membered ring we will write. It is 5 membered ring we have written. Okay, then rest we will write. Here it becomes O minus, so it becomes O minus. Here this oxygen is having 3 lone pairs. Then here CO, O, CO, CH2, pH is there. Here CO, O, CO, CH2, pH. Okay, next step is this O minus becomes OH. That O minus is becoming OH. Here 5 membered ring, O minus becomes OH, we can say. Then here what is there means CO, O, CO, CH2, pH. Okay, then removal of water. Next step is removal of water. Here this bond is coming here, this bond is shifting here. So removal of water we can say. Here we can say phenyl ring. Here 5 membered ring. Here pi bond is produced because of removal of water. Here CO, O, CO, like this we can write. Next step is hydrolysis. Next step, what in the sense hydrolysis? Here H plus we are writing, here OH minus we are writing. So right side is leaving as carboxylic acid. Left side what we are getting, you see, carboxylic acid we are getting. This is a alpha beta unsaturated carboxylic acid we are getting, therefore it is Perkin reaction. This Perkin reaction takes place within the molecule, therefore it is called intramolecular Perkin reaction. It is called what in the sense? Intramolecular Perkin reaction, we can say. Sir, next we'll say the test is called a Schiff's test. We'll see this Schiff's test is used for identifying aldehyde but not ketone. It is responding aldehyde but not ketone. Okay, we are taking Schiff's reagent. Schiff's reagent is what in the sense? Aqueous solution of magenta. Aqueous solution of magenta we are taking. This aqueous solution of magenta, another name is what in the sense? Pink colored rose aniline. Pink colored rose aniline, we can say. Pink colored rose aniline hydrochloride. Pink colored rose aniline hydrochloride. Okay, this is pink colored rose aniline hydrochloride. To this we will pass sulfur dioxide gas. This pink color becomes colorless. Pink color becomes colorless. Then we will add aldehyde. Then we are adding aldehyde. This pink color will be restored. Again we are getting pink color. Okay, aldehyde will respond. Ketones will not respond this test. Ketones do not respond this Schiff's test, we can say. Okay, next we will go for benzyne condensation. Next we are going for benzyne condensation. Next we are taking a benzyne condensation. Will take now in this benzyne condensation we are taking benzaldehyde. For this benzyne condensation we are taking benzaldehyde. Benzaldehyde we are taking. It is treated with what in the sense? Aqueous alcoholic cation. Aqueous alcoholic cation, and it is warmed. What we are getting in the sense? We are getting benzyne. We are getting a benzyne. How we are getting benzyne, that we'll see. We'll see the mechanism. This benzyne is called what in the sense? Alpha hydroxy ketone. Alpha hydroxy ketone. Alpha hydroxy ketone it is. Okay, now we'll see the mechanism in this one. Now we'll take benzaldehyde. Now we are taking benzaldehyde. First step is attacking of cyanide. Cyanide is attacking. Cyanide is attacking. This C minus is attacking carbonyl carbon. This bond is migrating to the O. So this phenyl ring here, this O becomes O minus. Here Cn here H. Okay, what is the next step? That we will see. Next step is this bond is migrating to carbon. This H plus is attacked by O minus. This carbon becomes carbanion. Here cyanide. Next, this carbanion is attacking benzaldehyde. That carbanion is attacking benzaldehyde. This C minus is attacking this carbon. This bond is shifting to this O. So what we are getting in the sense? pH, COH, here Cn, here what means? CO minus, here H, here pH. Okay, like this we are getting. Next step is what in the sense? From here H plus transferring to this place. From this OH group, H plus is going to this O minus. So we are getting pH C, this O minus, here Cn, here COH, H pH. Okay, this OH is donating H plus, therefore this O minus taking that H plus. So it is OH, it is also OH, no? Then why H plus is transferring? This is OH group. This is also becoming OH group. Then why H plus is transferring? Because of electron withdrawing group cyanide. This cyanide makes more basic here. Therefore, it is giving H plus to this. Okay. Next step we will see. This O minus is having 3 lone pairs. Therefore, what happens? We'll see. This lone pair becomes pi bond. This is leaving. Cyanide is leaving. Cyanide is leaving. Therefore, pH C double bond O CH OH pH. Okay. This is a alpha hydroxy ketone. You can say it is ketone functional group. It is alpha carbon. At alpha carbon hydroxy is there. Therefore, alpha hydroxy ketone we can say. Out of ketone and alcohol, which is main functional group, means ketone is the main functional group, alcohol is substituent. This reaction is called benzyne condensation, we can say. Next reaction we'll see. Now we will take benzaldehyde. In the benzyne condensation continuation, we'll see benzaldehyde we have taken. Then paramethyl benzaldehyde will take. Paramethyl benzaldehyde will take. Then we will treat this with aqueous alcoholic KCl. Aqueous alcoholic KCl. Okay. So we have taken benzaldehyde. Benzaldehyde we have taken. Paramethyl benzaldehyde. Okay. Aqueous alcoholic KCl. Okay. What is the product? What is the product we will get? That we will see. Okay. So we will see the mechanism. First step is attacking of cyanide to the carbonyl carbon. Cyanide is attacking carbonyl carbon. Now, which carbonyl carbon will be attacked by cyanide? That we have to see. Which carbonyl carbon out of these two, which carbonyl carbon will be attacked by cyanide? Sir, which carbonyl carbon? That we want to see it. Now, here benzaldehyde is there. It is a partial negative, partial positive here. In paramethyl benzaldehyde. Now, we will take paramethyl benzaldehyde. Here also partial negative, partial positive. Now, which is having more positive charge? In the sense, here positive charge magnitude is more, here positive charge magnitude is less, because this methyl group shows hyperconjugation. It is electron donating group. Therefore, here partial positive charge magnitude is less, here magnitude is more. Therefore, cyanide is attacking this carbonyl carbon. Okay. So, cyanide is attacking this carbonyl carbon. Okay. So, what will happen in the sense, next step, what in the sense, this cyanide carbon, this carbon is attacking here. Therefore, it becomes O minus. Okay. It will become O minus. So, pH, CH, CN, then this become O minus. Then this bond is shifting here, H plus is going here. So, we will get here cyanide, this carbon lone pair negative charge, here OH. This C minus is attacking this carbonyl carbon now. This C minus is attacking this carbonyl carbon now. Okay. So, here methyl group, here phenyl ring, here aldehyde group. Aldehyde group. Now, how the attack will be there, we will see. This C minus will attack this carbon. This pi bond will shift to this carbon. Okay. Therefore, pH, C, OH, here CN, here CH, O minus, here 3 lone pairs, 3 lone pairs, here phenyl ring, here methyl. Next, what happens means, from here H plus transfer to this place. From here H plus transferring to this place. So, pH, CCl, it is O minus, CH, OH, here phenyl ring, at para position methyl group. At para position methyl group. Then next step we will see. This is O minus here is there. Now, this lone pair is shifting as pi bond. This bond is shifting. This Cn minus is leaving. Cn minus is leaving. So, we are getting a pH, COH not, C double bond O. C double bond O. This CH, OH. Here phenyl ring. Here methyl. Okay. So, like this we can. This is the product. It is called benzyne. It is alpha hydroxy ketone. It is benzyne, we can say. So, how to say by seeing the reactant, how to say the product, will see. So, which carbonyl carbon is more electrophilic? First, we have to identify. Okay, that carbonyl carbon becomes ketone. That carbonyl carbon is making bond with this carbonyl carbon, and this O becomes OH. Okay, this is the product. Okay, so we have to see, this is a, we have to see which is more electrophilic carbon. We have to see out of two carbonyl groups, which is more electrophilic. We have to see this is more electrophilic when compared to this, because here more positive charge, because it is less positive charge. Why? Because the CH3 group shows hyperconjugation, it is electron donating group, therefore it is more electropositive, and that means here more positive charge is there, so cyanide will attack this carbon. So this carbon, this hydrogen will go to this oxygen. Okay, how to say the product, that will see. This CO we have to consider, this hydrogen will go to this O becomes OH. Then between this carbon and this carbon bond will be produced. That is a product. Seriya? Okay, this is called a benzyne condensation, but here two different aldehydes are there, therefore it is called a mixed benzyne condensation. We'll call this is as a mixed benzyne condensation, we'll say. Okay, next benzyne condensation continuation. Here NO2, phenyl ring, CHO, then Cl, phenyl ring, CHO. Okay, now two different aldehydes given, which is more reactive? Which is more reactive carbonyl carbon, that we have to see. Which is more reactive carbonyl carbon? Okay, so here double bond O, here H. Here double bond O, H. Okay, this carbon is having partial positive charge, this carbon also having partial positive charge. This NO2 group shows minus I effect and minus R effect, so that it is a completely electron withdrawing group. Cl shows a minus I effect plus R effect. Therefore, electron withdrawing nature of NO2 is more when compared to Cl. Since electron withdrawing nature of NO2 is more, magnitude of positive charge is more here, magnitude of positive charge is less here. Okay. Therefore, cyanide will attack here. That means this will remain as C double bond O. This hydrogen will go to this place. This will become OH. This carbon and this carbon bond will be produced. That is the product. Okay. So ONO2, the phenyl ring, it is more reactive. Therefore, it will be C double bond O. This hydrogen goes to this place. Okay. This carbon making a bond. This becomes OH, and this hydrogen as it is. Then phenyl ring, then Cl. Okay, this is the product. This is the product here. Sir, next mixed benzyne condensation. Next reaction we'll see. Here ethyl group, here phenyl ring, here aldehyde group. Okay, another aldehyde is here methyl, here phenyl, here aldehyde. Okay, now mixed benzyne condensation. What is the product? We'll see. Now, which carbonyl carbon is more reactive? We have to see. Okay, here positive charge is there, here positive charge is there. Where magnitude of positive charge is high. That means this methyl group shows, in the methyl group 3 hydrogens are there. These 3 hydrogens showing hyperconjugation. Here ethyl group, in the sense we can write this is as CH3, CH2 we can write. This is this CH2. These 2 hydrogens showing hyperconjugation. Here 2 hydrogens showing hyperconjugation. Here 3 hydrogens showing hyperconjugation. So electron donating nature is high, electron donating nature is less. Therefore, here magnitude of positive charge is more, magnitude of positive charge is less. So cyanide will attack this carbonyl carbon. Okay, that means it will remain as CO. This hydrogen will come to this place. This O becomes OH. Between this carbon and this carbon, bond will be produced. That is the product. Okay, now we will take ethyl, then phenyl ring. This is becoming, this will be C double bond O. This carbon is making bond with this carbon. This is this O becomes OH. Then this phenyl ring and methyl. That phenyl ring and methyl will write. Okay, this is the benzene we are getting. Okay, next we will see benzylic acid rearrangement. Next we are seeing benzyl benzylic acid rearrangement. Benzylic acid rearrangement we'll see. Okay, for this we have to take a benzyl. We have to take this benzyl is called what in the sense alpha diketone. Alpha diketone benzyl we have taken, that is alpha diketone. It is treated with base OH minus. We are getting what in the sense alpha hydroxy acid. Alpha hydroxy acid, it is called benzylic acid. It is called benzylic acid. Okay, so benzyl alpha diketone, the alpha diketone will take pH phenyl ring C double bond O phenyl ring. Okay, alpha diketone benzyl. It is treated with what in the sense sodium hydroxide, that is OH minus. Sodium hydroxide, that is OH minus, we are treating. Now what is the product obtained? What is the mechanism? We'll see. This lone pair is attacking this carbon, this bond is shifting, so we are getting a this phenyl ring, this C double bond O, then here COH, this O minus here phenyl ring. Okay, next step what happens means, next step is what in the sense this lone pair is shifting here, this bond is shifting to this carbon, this electron cloud shifting to this carbon, this electron cloud shifting to this carbon, this oxygen. Now phenyl ring will write, then here this O minus will write, this O is having 3 lone pairs, here phenyl ring will write, here carboxylic acid will write, carboxylic acid. It is acid, it is base, therefore H plus transfer. It is acid, it is base, therefore H plus transfer, we can say this bond is shifting here, H plus is going here. Therefore here phenyl ring COH here, this O minus becomes OH, this phenyl ring, it is what in the sense COO minus, it is COO minus. Okay, COO minus. If you give H plus, this COO minus will become COOH. COO minus will become COOH, we can say. It is called a benzylic acid rearrangement. Okay, let us go for next reaction. Next reaction will take a what in the sense CH3 C double bond O phenyl ring. Okay, we have taken alpha diketone, we have taken this, we will treat with OH minus, we will treat this with OH minus. Now OH minus will attack carbonyl carbon. Okay, the carbonyl carbon are unsymmetric, here partial positive, here partial positive. Where magnitude of partial positive charge is more, that we want to know it. Okay, where magnitude of partial positive charge is more. Okay, here what happened means this pi bond will shift here, this pi bond will come here, therefore resonance. It is electron donating group, it is electron withdrawing group. Here what happens means this shows hyperconjugation, therefore here magnitude of positive charge is more, here magnitude of positive charge is less. Okay, therefore OH minus will attack this carbon, OH minus will attack this carbon. OH minus will attack this carbon. Okay, so OH minus is attacking which carbon, we got an idea, therefore this OH minus is attacking this carbon. Here C double bond O, here phenyl ring, here we have written phenyl ring. Okay, so next step we will see. Next step, what is the next step in the sense migration of group? What group will migrate in the sense methyl will migrate. This is lone pair coming as pi bond. This methyl takes this sigma bond and goes to this carbon. This pi bond goes to this oxygen. Therefore, we are getting a this OH C double bond O, here CO minus, here CH3, here phenyl ring. Phenyl ring. What is the next step? Means from here H plus transferring to this place. So O minus, C double bond O, COH, CH3, this phenyl ring. Okay, it is called benzyl benzylic acid rearrangement. So by seeing the reactant, how to say the product? So first what we have to select in the sense, in the alpha diketone, if it is unsymmetric, which carbonyl carbon is more reactive? First we have to select it. To that carbonyl carbon will become COO minus. OH minus will attack that carbonyl carbon, that will become COO minus. And in that carbonyl carbon, what group is there? That will migrate to neighboring carbonyl carbon. So this CH3 going to this carbon. Okay, this is the product. Then this O will become OH. This double bond O will become single bond OH. Okay, so now we will see. Now we will take the reactant, here phenyl ring, C double bond O, C double bond O, then phenyl ring, here OMe, OMe we have written. Okay, now two carbonyl groups given. Which carbonyl group is more reactive? That we have to select it. For that case, this phenyl ring shows resonance. It is electron donating group. It is also electron donating group. But additional what? This will show plus R effect. Plus R group. Plus R group. Therefore, it is better electron donating group than this. Therefore, here magnitude of positive charge will be more. Here magnitude of positive charge will be less. Therefore, this carbon is more reactive carbon. It is more reactive carbon because it is better electron donating group than this. Therefore, this carbon is having more positive charge, therefore more reactive. So OH minus will attack this. Therefore, this carbonyl group will become carboxylate anion. Then this phenyl ring will shift to this carbon. This phenyl ring take this bond and shift to this carbon as phenylide shift. This O becomes OH. Okay. So this will become carboxylate anion. This C double bond O becomes C single bond OH. This phenyl ring shift as phenylide shift to here. Phenylide shift, therefore here phenyl ring we are writing. This we will write it. Paramethoxy phenyl ring we will write. Paramethoxy phenyl we have written. This is the product. It is a COO minus here. It is a product we can say. Sir. Next, in the benzyl benzylic acid rearrangement, next compound we will take. It is a cyclopentane. We will take this one in the form of a diketone. Alpha diketone we have taken. Now OH minus will give. Now OH minus will attack which carbonyl carbon? Any one of the carbonyl carbon we can give. Okay, sir, OH minus is attacking this carbon.